All right, for this question, they're giving us the function f of x equals x squared plus 5 cosine x, and they're asking us how many times this function changes concavity on the interval 2 pi n. So what we're going to do is plug in an n equals 1 first and find out how many times that this happens on the interval 0 to 2 pi, and then we're going to multiply that number of times by n. So what we're going to do first is go into our TI and plug in, does not want me to move it, here we go, plug in the function x squared plus 5 cosine x. So come over to x squared, x squared plus 5 cosine x. And I want to know how many times there are changes in concavity, so I'm going to need the second derivative. So I'll go to alpha trace y1 and I'm going to go to alpha window, choose the n deriv, then plug in an x for differentiating with respect to x, then go to alpha trace y1 and then make x equals x to graph it for all x values. Then we're going to do that same thing again, alpha window, n deriv, put an x here, then I'm going to do y2 here because now I want to take the derivative of the function in y2, and again we'll do it for all x values. Then I'm going to come to my first two equations and hover over the equal sign and hit enter, so those two equations are no longer highlighted here, so they will not graph. And if you recall, we're going on 0 to 2 pi, so I'm going to set my window to be 0 to 2 pi on the x-axis, and then my y-axis I want to be somewhat close to the x-axis, so I'll just go from say -5 to 5. I'm going to hit graph, and I'm literally just going to count the number of times that this graph crosses the x-axis. Takes it a while to graph because it is the second derivative, and I'll know when it's done when these little lines stop spinning. Coming back down, and it looks like the answer is twice on the interval from 0 to 2 pi. So again, I'm going to multiply that number by n, and my answer is 2n.